So if you open the model which I shared to you in the WhatsApp group, you'll have something like this one. So in 3D, this is the mode of commercial building in 3D view. It's a plain model without any infrastructures. So we'll go through on how to design a HVAC system for this commercial building. So you can see, if you go to level 1, you see this one is we have here cafeteria area, we have a TV room, we have office 1, office 2, and here we have a washroom, ladies and men washroom. Is we have a meeting room. So we'll see how to design a HVAC system depending on each category of the space. So if you open Revit 25, you'll have the interface like this one. You'll have interface like this one. So when you came here, you will see the account details. Your details, Autodesk account details, about the purchasing details, private setting, sign out. When you open the model which I shared to you on WhatsApp, you will see a message coming which is say upgrade the model, and the second one say cancel the upgrade. So this model was made on the previous version of Revit. So when you open in a higher Revit version, it needs to upgrade that model. So click upgrade model. So when you click upgrade model, the dialog will happen which will update the model. Another thing to note is that when you are using, for example, Revit 2025 model, you cannot open it on the lower version of the Revit. So 2025 model not be open on 2024 or 2023. So after you open and upgrade the model, here on the top there is a small icon which is like a building. So you click that icon. Click that. So when you click that, it will show the 3D view of that model which we instated. So I think everyone is able to reach this stage. So here we have a Revit user interface. We have here file. We have file. In the file we have new. The new, when you click new, there's a project. There's a family, conceptual mass, title block, annotation, and here we have option. Here we have exit. So under option, here we can set we can change the colors. For example, now my background is white. So when I came here, canvas color scheme, I can change it to dark. So here under the file, go to option. Go to option. So click option. Under option we have first one we have general. Under general, notification, Save reminder. This save reminder is when you open the model, at which time a reminder will occur and remind you to save the model, save every change that you have made. So you can set each time you want. We have 15 minutes, 30 minutes, 1 hour, up to 4 hours, or no reminder. So here, synchronize with central reminder. This is work with the collaboration. We'll see later. In the collaboration, when you have a central model, you want to centralize. Maybe you do collaboration with other disciplines. So the model will be stored in the network. So if you want to save which, to remind you to save which after every time. So we have username. In the download we have Donald cleanup. So after you setting the files, sometimes you may set maybe to have 3 backup files. So after which number exists, for example here 10. After 10, it will delete it automatically. And here we have days, which the file which I save. We'll see when we come here to save the file. We'll see how to deal with this one. So here under user interface, you can select which option you want to see. Here there is actual, we have structure, we have system, we have typing. So also in HVAC mainly deal with mechanical template. So here you can see the mechanical analysis tools is tick on. Also piping on. So if you untick one option there, so it means that you cannot see the associated items. So now we can leave at it is there. Here we came to keyboard shortcuts. You can customize the shortcuts. I will show you. We'll see in the view tab. We'll come and see. So here on the colors, you can change if you don't like a white color, you can change the color. For example,
the color of the beauty.
No, I mean the color of the background workspace. The color of the workspace.
Yes.
For example, here now you see my background is white.
It's white.
I can change it to maybe dark. So click dark, then apply OK. So the background will change. You see. So if you need maybe to white, you can go again and the option colors. You can click white, or even you can set the color which you want. Here there is a lot of option of colors. You can set the color which you want. So for now, for me, I'll go is light. So here under graphics, it show you other option which can live with is at ease. In the hardware, it show that how compatible your computer is with the Revit models. The file location. Here we choose the path route for when we want to save the file. For example, Revit families, and there you can choose the path which you want to save. So you can go here in console, go to see another tab. Here when you come to this tab, we have architecture, we have structure, we have steel, we have precast system up to modify. So mostly in the HVAC we deal with system tabs. Yes. So under system tabs, we have the panels, we have HVAC HVAC panel, fabrication, MEP detailing, P&AD. P&AD mostly is for cutting. With mechanical, here we'll have a plumbing panel. Go to system tab and click system tab. So mostly in HVAC, we deal with a system tab. Under system tab, we have a HVAC panel. Yes, we have duct placeholder, duct fittings, duct accessories. For example, dampers, filters, smoke detectors. Yes, we can convert the rectangle duct to flexible duct. So all of this will check each one how it works. We have air terminals. So again, we came to another tab is called insert tab. And the insert tab, it works how to insert the data to Revit. You can insert the Revit model. You can link IFC. You can also link another type of cards.
What IFC?
Yes, this link I would say if you have is a type of file, another type of file. If you have, you can open. It's a different type of file extension. Yes, it's a type of file extension. Same maybe like DWG. Yes. So mostly here we'll be working with a Revit link, import card, load families. So I will be working with this panel. This link on insert, yes, on insert tab. So, for example, when we go to a mechanical template, we'll see how to insert the model. So now, when we open this model, now we are in architectural template.
Okay.
Yes. So when we go on, we'll see how to use this. So another thing.
So I can draw that models on this workspace.
So picture model.
Someone draw, then you can.
Yes.
Okay.
Yes. So this model was properly modeled by an architect, and we architect shared to us. Also, we have. If you want to have the models, there's different websites. You can go and download. So, for example, there's one website which is called Bibliocard. Bibliocard. This one. Yes. It's a website which you can get the different. This one I show this one is biblocad.com. So when you go on this website, you can download the already modeled the Revit models. So it will be easy for you to work on. Yes, there are different kind of models: single story, double story. Yes, so every kind of model which you need to work on will be available here. So another website in which you can get it's called the GrabCAD. Yes, GrabCAD. GRABCAD. So this is a website in which you can go and get the Revit models. So after insert tab, we have annotate tab. Yes. This annotate tab will be using to check the dimensions, to mostly in scheduling. So if you see here in the training diagram, A5 will use mostly annotate tab for the A5. Here, for example, generating schedule for component, applying tags, labels, adding dimension. So all of that are annotate tab. We'll see how it works on the A5. So we can go now. Another tab is analyze. Click analyze tab. So under analyze tab, we have a structure analysis model, but mostly we will not use this one. HVAC will use the spaces in the zone. Yeah, in the spaces in the zone. Also, we'll use report in the schedules. Report and schedule panels. Also, we'll use this check system panel. Another will use energy optimization panel. So under this analyze tab, we'll use this group of panels. The electrical analysis routing can be used on another discipline, maybe electrical design systems. This is structure used by the structures engineer maybe. So mostly HVAC will deal with this 4 tabs, 4 palettes. We're coming again, massing inside. Massing inside tab. That in HVAC design will not use this one. This is mostly used by the architects. So another thing will use this collaborative tool. As you know, Revit used by different fields, architects, structural engineers, electrical engineer, mechanical engineer. So this Revit consists of the every aspect. So this we are dealing with HVAC system design. We'll only select the corresponding palettes, which will be basically on the HVAC systems. So here under collaborate, this is under collaborative view, panel. The use of collaborate panel. For example, you are working on a project with another people, maybe architect, maybe civil engineer, electrical engineer. So this will help us to have one model which will be updated maybe in the servers. So even architect make changes or anything updated in the model on the server, you can come here and see. Mostly deal with collaboration between the disciplines. So we'll see how this one works, but I'll show you how this one works, maybe to compare the central model, to share the model for other disciplines, and see how everything goes. So another thing which you will use most is view tab. Under view tab, we have a view template visibility graphics, filters, scene line. So for example, mostly we use this one. Mostly we use this view type to create a section view, a plan view. So most of the time will be based on view tab. For example, this on your model, when you are in 3D view, then you can come here on the left side, you click level 1, double click level 1. It will open the view of the first level of this building. View of the first level of this building. So, for example, so let me change my background to white. Let me change my background to white. Okay, now we're good. So when you open this plan view, level 1 plan view, if you want to look to see the vertical section of this plan view, because this one is we look on the top. So if you want to see a section view, we come here on the section, and the view tab will come on the section. You click section. After clicking section, you come to your model. You see this cross mark. Click, left click. Left click. Then move your cursor up to the end of the model. So now I move it to my right hand side, and then I left click. You go here to view, then left click section, view, left click section, left click one time, yes, one time left click. Then you will see your cursor change to cross. Yeah. Then left click one time from the place where the building starting. Move your cursor up to the building and finish line. So I can repeat it again. To see. Go to view tab. Then click section. So in section we want to look the section of the building, because now we are viewing it on the top. So we want to look to see how it looks on the section. So you click section, then it will show the cross. The cross will change to cursor. The cursor will change to cross sign. You left click one time, moving the cursor right up to the model where the model ends. You left click again. So when you left click again, it will cause this one view. This section will be created. So you can also extend its boundaries. For example, here upward, I hold this, move it upward. You can move it downward. For example, when I move it up to this here. I move it small up. I will only see this section.
Sorry. That's the top. Okay.
This is a level 1 top view. So I want to see the cutting, like a cutting. Yes, from the top to down. Yes. So when you are in the section, when you move this, you can customize it and see the things that you want. Yes. When you move this one, you can move left, right. Example, want to see maybe this area if only. I want to see if only these places. So I move up to this cave only. And here I can move this one. So after that, go to. After that, I click on the open space. Left click one time on the open space. So when you click on the open space, then you go here like something like a cycle with a arrow. You right click. Sorry, I repeat again. I repeat again for you to capture. Let me delete this section. I come here on the view tab. So my aim is I want to view this building because now we are on the top view. I want to see there's a details vertical from the first floor up to the last floor section. I want to cut this building. So in order to see the so I come here to view. Come here to view tab, then select section. After select section, the cursor will change to cross. I left click one time until the end of the building. I left click second time. So as I say, you can move it, you can customize it to see which area you want. So left click again, hold to right. I want to view this cave area. Also here we can move up to here. So when you move that to the open space, left click one time. Then come to here, the cycle which have arrow. It's like watching. It's watching this side. You can change it to watch another side. So for now, if you want maybe to change to watch opposite side, you just left click one time. Then there's this arrow direction, flip direction. So when you click that, it will change the viewing direction. You see this arrow looking opposite direction. So that is how you can flip the section view. So click again, left click again, click this one. Flip section. We will build. It will be like we are looking this cafeteria area. So after that, click on the open space. Then go to this arrow. Cycle with arrow. Right click. Then go to view. When you go to view. When you go to view, something like this will show up. So it's it's cropped. So you can click this the most outer box. You can click it. You can extend it. The crop view. You can extend this crop view. You see the whole building. So for now that section we created, it opened another window that's called the section. You can see section, the name section 4. So back, remember we are on level 1. So this one is a section 4. So on this section 4, you can see how the building is from the first level up to the 7th level. So you can, if you go again to level 1, you can maybe I want to see only this place. You can moving around and see. So that is how to create a section in Revit. So
on section 4, and I rotate to view either side or whichever you want to see.
So you cannot rotate the section view. This is only 2D. Section view is only 2D, cannot be rotated. So if you want to look this side, maybe look this right side, you come again to levels. Level 1. Level 1 is our main blade. So you create another section which look this side, right side. So you can come here and view, then select section. You create another section to see this side of the building. Yes. So you are like before, the red arrow means the crosshair. Then you will move down the cursor. Make sure it is straight. Don't make it yes. Make sure it is moving straight. Then you left click. After you left clicking, you have to make sure the boundaries of the view is inside the building. So for example, now you see our section is looking opposite side. You can look at this cycle with arrow. It's like facing opposite side. So when you open that, you cannot see anything. So you have to flip it here, double arrow. When you click this left click, when you click it, flip section. So we flip it, but you see here the boundaries is not in the building. So when you open it, you will not see anything at all. You have to move this section inside the building. So for example, it is there. When you go to view, you will not see any building. You see, you only show levels. So we have to make it come to the building boundaries. Yes. Extend it. So when you extend it, it will show your view. So another thing, this boundary, the crop region. Increase it. You can increase the crop region to see more.
Like zoom.
Yes, no, like extending. Seems like you crop the picture, so you want to crop to see more details. So mostly we will work with this view section. Most of the time we'll work with this one. So another thing, when you want to click this, then you come here. Then you see more.
Like now I'm interested to see either one floor or
Yes.
I want to check it.
What to?
Like I want to check on the first floor on interested level, like level 1 or like I can like section it. Have a section of it.
Yes. Yeah. For example, if you see this section 4, if you open it, go to view, we see the whole building. So yes, so if you want to only to view this this level 1 to level 2, you just click this crop view and you crop it. So you will only see
and you can move
first
this
level.
one this side.
Yes. So also you can move it to the right. You can make it small. Yes. So this is you use the crop option. So if you want to, for example, if you want to disable this crop option, you come here downward. Come here down. There's a small icons. The one which called the ID crop region. If you click ID crop region, that crop option will not be visible. So you can see here now how I cannot again crop this view. I cannot again crop this view because I had that. So if you want to put it back, you go again there and show. You click one time show crop region, so it shows up. So you can also move it and continue to crop it. Yes. So sometimes another option here under the section view, so sometimes maybe I want to hide something. Maybe I want to hide this tables. I want to hide, maybe hide, or maybe sometimes we want to hide any element, or even it's that thing that you want to hide. So you click that item. For example, here I want to hide this furnitures. So you click one, right click, then come to hide in view. So hide in view, we have element category. So if I click hide in view element, I will hide only this one round table. So if I click hide category, I will hide all table. Yeah. So for example here, element only one table is hidden. So if you hide element, how do you do the back? So you come here, will hidden element. There's a small like a bulb. You click it again. You will see the one element with the red mark, red circles. So you left click, then right click. You come to unhide view. You click element. Then you go back to close, reveal, hidden element. So this apply on each element, whether it's this pipe, whether it's end unit, anything, each element is apply on every element. So another thing before we move to the manage tab, under here we have detail here downward. When you see here down, we have detail view. When you click that one, you can change how you want to see this model. For example, if you choose medium,
so it's like a half of that plane. I want to do this side without sectioning like this one, this area. I'm able to see it.
you want to
Just to view in.
use this one area.
Yeah, like this one here.
So you can use you want only to see this toilet area.
Okay, not exactly anything that I want to view it in detail. Like I'm not interested in sectioning, whichever, but I'm just interested to see what is in there.
Yes, we can use this. We can come here in the 3D example. You click here. You can use this scope box. We'll see there. We'll see how to use this. This is scope box. Yes, if you want to view individual thing, we'll see more when we're starting with deducting modeling. We'll see how to use this one. So click again, reveal so we are still on this user interface. Here downward, we have an option. Let's review this option down here. We have fine, we have medium, we have coarse. So this is basically show how the clearness of element. So if I click fine, it will show the good view. If I click maybe coarse, it only shows the lines. We'll see when we start doing the dots. So here we have when we came another box, we have wireframe, hidden line, shaded, consistent colors. So when you click wireframe, different view changes. When you click shaded, it changes the color. Only to improve the visual of the model. So if I click realistic, so when I click realistic, I will show the good to show the good graphics of the model. So this option also it is demanding more power of computer graphics. So that's why when you click it will be sometimes loading. So this view, if you want to see the clear graphics of the model, you click realistic. So as you see here, the model has changed and the visual is more appealing. So this one when you want to okay, so now we move again to the tab. There we move to the manage tab. The manage tab, we have the palette setting palettes. We have project location. We have design option, generative design, manage project. We have selection, inquiry, extension. We have visual graphicing, Dynamo. So here under manage, we can set the project parameters. We can set the project units. So for example, so this project unit you see item number 3. Let's continue according to our syllabus now. That project unit you will see on item number 3, how to set up project template and project units and parameters. So by following our calligram, and now we are on the views, panel, and ribbons. So how to set the project unit, we will see on item number 3 when we continue moving forward. So let's go again, continue.
Like requirement of the project that's like loading.
When you say parameters, we use the scheduling. So for example, in working with HVAC, we have different parameters for HVAC. maybe you can see we have for cooling load, maybe we have BTU hours, we have kilowatts. So the energy, yes. So for example, if we go to that design, we have different parameters. So every design aspect have its parameters. So when we come to project parameters, we'll group each parameter according to its field. So the main reason is during the taking of the scheduling of the detailing. So it will be easy to take the detail according to the parameters. We'll see more when we reach that part. Setting up with the parameters, it is number 3. So when we continuing now according to the syllabus, we are still under review panels ribbons. So now we are going to add-on tab. So this add-on tab, if you want to install another setting which will help you, or program which will help you to on your work. So basically this add-on, you come here to Autodesk App Store, the smaller like a trolley, this icon. When you click this icon, it is where we will get the add-on. So when you click it, it will open. So this is basically a Revit market for different tools. So all of this is called add-on. So for example, you can select mechanical design. The mechanical design, you select your version, Revit 2025. You select your operating system. I'm using Windows, depending on which system you are using. So here you get the tools, the different tools. Another one for sale, another one free, depending on its usage. So all of this add-on which will help you to on your project. For example, we want to create automatic duct hanger. There is a tool which can help you doing that. So when you want to when you download it, it will come here on add-on section. It will help you to do your work. It's like automation your work.
So we need to together with this one or to open another software.
So after you download, for example, let's download the one with free version. After you download it, it will be attached to this private software. So we see this blank area. It will come like another menu here. So depending on which we want to use, we'll see more when we model advance. So we came to modify tab. The modify tab is basically it's like more like a modeling. Mostly we use this modify palette. We have align, we have offset mirror, we have a mirror with draw access. We have to move. For example, I want to move something, maybe I want to move this section. I click move. I can move it. We'll see more when we come to the duct section. we have here measure. I want to measure the length. If you want to measure the length of everything, we can come here and there modify tools. Yes. So for example here in the alignment, for example here I draw something, I want to align it. I'll show you more when we coming to number 4, family types. We'll use more that one on this, creating map families. So according to our flow, now we're going to begin to key tools for map design. Going to see the key tool for map design. We already see the workspace, how the visual interface of the map is. So now we're moving to key tools. Tools for MEP. We'll see. We come here and to see the key tool which you use. So in general, in MEP, we have tools which will help us to facilitate our work. So the first one key tool is building modeling. So as a building modeling, we enable us to create the 3-dimensional of the building, the collaboration with other. The best key is BIM modeling, building information modeling. So for example, in building information modeling, we have different softwares which will help us to create the building models, collaborations with other departments, other fields, other professionals, such as architects, structural engineers, electrical engineer, mechanical engineer. So here we have Revit MEP. So one tool for map is Revit MEP. Can be another innovation, for example 2025, 24, and innovation. So we are using Revit 2025, the latest version. Here another building modeling software example, we have AutoCAD. So the most important benefits of this building modeling, it enables us in coordination, so between the discipline. Example here, you see this picture. This picture show building which inside consisting of ductwork. Also, we have here the firefighting pipes. We have here plumbing pipes. Down here we have plumbing fixtures. So Revit MEP help us to coordinate all these systems in the building. Know each system, how it is arranged, how it will be routed, proper routing. So assuming, for example, you don't have a Revit, how will you know this duct will not crossing over the pipes or any interference? So before the interference happen, you can figure it early at the designing stages. So when you move to the construction, it will be easy. The clashes will not occur because all the clashes will be solved in the modeling stage. So here is an example showing how each system integrates and is coordinated without any clashing. So importance of BIM modeling. Also, it can help us in analysis and simulation of MEP system. Another thing is provide a solid foundation for building maintenance. Also, once building code is completed, also can be used to monitor, for example, maintenance, or to review as build drawings. So, as a second tool for MEP is calculation and simulation software. Under the calculation and the simulation software, mostly usually for energy airflow system. So, the software which are popular in this category, we have Trace 700. Trace 700. We have Career HAP. We have Elite CHVAC. So that this one is the most popular software for simulation, energy analysis, and the airflow. So, for example, here we have a user interface of a hub, short term of career hub. So in this interface, you can see here we have project, edit, view, code. So this hub, career hub software, mostly usually in calculations of loading, heating and the loading calculations. Usually, for example, in the chiller sizing, it is advanced software which most of the HVAC designers also should know how to use this software. So another thing, the third tool for MEP is computer-aided design tools. So under this category, also Revit also is again in this category. For example, here we detected the clash, which show the model here with the ducts crossing the pipes. So this one, another tool, another advantage of Revit is that it can detect the clash. As you see here, when we did the system inspection, we saw there was the ducting was crossing through the pipes. So it is easy to make the routing of the pipe and the ducts to avoid this collision. So as you see here, it is important in automatic creation of materials, detection potential collision, and design area. For example, this one is we detected a collision during the design phases. So the importance of this one, save time. For example, assuming you are building and suddenly we see there's a collision. So we will take time and the approval until the maybe reviewed it. So the project timeline will be longer. So during the design, we avoid that. That is another tool for MEP. So even if in the software phases, design phases, we can make the change quickly. So we reduce the error at the stage, design stages. So the first one is project management tools. Project management tools usually to coordinate different phases of the design. So here we have for example, we have Vamera 6. This is a type of software which usually as a project planner, project managers to plan the project. Another is Microsoft Project. So this one helps them to monitor and plan the project progress. Also facilitate the communication between the project teams and the stakeholders. That is the importance of project management tools. So the first one is a cost analysis tool. This cost analysis tool, another tool for MEP, it helps us to check the cost of to predict the size cost of the project. So most one usually in cost analysis, Revit can be used. Another one is a cost X. There's a Revu. So this one helps us to optimize the cost of the building. Also, it creates the transparency of the project cost. So everyone can see and see the budget of the building, of the project. I mean, we can evaluate the alternatives to see. So one about managing the cost of the project. That is another tool. So during our time, the software which will be mostly using in our training. The first one is Revit 25 Vision, which one I already shared on your email with the with our paid version, and the keys already shared. We have. So another one will use Excel, Microsoft Excel. We'll use Career HIP for calculating the heating load for designing sizing the equipment. For example, chillers, we'll use this one, Career Hub. Also, we use Daikin Macquarie duct sizer. This one we're using in sizing the duct. DAIKIN MCQUAY duct sizer. So we'll see how to get this software. The third one is Xylem pipe sizer. This we will use to size the pipe, which will supply the fluid to the cooling coil or heating coil of the chillers. So we'll use to size the pipe for this pipe size. Xylem XYLEM pipe sizer. So up to now we solve the key tools. We solve the key tools for MEP system. So how do we now? Let's see how do we get this software one by one. So for example, Revit. Already, every one of you already received the link which you to download the software. So some of them already downloaded. So we'll see how to help other people to continue installing this software, Revit. So yeah, we have a Career Hub. So Career Hub, there's a trial version which you can have. So to get this trial version, Career Hub provided the trial version. So you can go to the browser and type Career trial. clear hard drive. Here you can get a Java version. For 90 days. So when you came here to redesign free tile, so you come to e-design free trial, they want you to fill your information, which software you want. Here we select the hourly analysis program. You put your names, email address, phone number. You fill every detail there. Then you submit. So after submitting, for example, you can put your detail there. So when you fill all the detail, you submit. Then they will give the detail for how to download that file. So it usually take 1 to 2 days. So let's come to Daikin Makwai. This Daikin Makwai sizer, it is a free, but available with no cost. So to get this software, just only go to just go type the Daikin Makwai sizer. It will have the Daikin applied, the first website called Daikin applied. So you click design software tools. That will scroll up to down. Then you scroll up to down, then go to Daikin design tools. Under Daikin design tools, you select size in the calculator. Size and calculate that work. You click that one. Then it will download that size. So yeah, this one of course you need to download and install. When you reach to the ducting sizing, you'll use this software to size the ducts together with Revit. Most of the time we use Revit. So also we have another one which is Xylem pipe sizer. You can just go and Google and download it. You use it for sizing the pipe for submitting the cooling refrigerant or water, cooled water from the chillers to the cooling coil. So when you click the Xylem, you download that sizer software. So this one is free of charge. You can hear system sizer for window. So you agree to the terms and condition, then it will download. After downloading, we will install. So that's what the software will be used on our session. So now we're moving to another part, number 2, which is understanding HVAC systems and components. So here we are doing introduction to HVAC fundamentals. We look at the key components of the HVAC systems, that ducts, pipes, air handling units, fans, and valve. Also, we will see overview systems of heating system, ventilation system, air conditioning system. So basically, HVAC stands for heating, ventilation, and air conditioning. So HVAC is about creating perfect indoor environment. So commonly we say HVAC. So another thing is called another term is called indoor environment control system. The same as the HVAC. So this one is more accurate. So I will share with you this notes for you to review. Yes. So I'll share the link to download this note. So on heating, the main purpose of heating is to create the warm low temperatures. So for example, in winter's season, the temperature is very cold, so we want to make the indoor air warm using the heating system. So basically, heating comes from furnaces, which this type of furnaces which usually use burn fuel like gas or oil to create heat. Then that heat can burn water. Hot water can be transmitted through to the heating coil of the air handling unit, and air handling unit provides the hot air, warm air in the rooms. So basically, you can see this one. This is this drawing which show heating system, heating unit. So now we have here boiler. So these boilers use electric boiler can use electricity, or maybe can be use natural gas. So to boil the water. This water is pumped up by this motor. Pumping motor then go to air handling unit. This air handling unit inside it have the coils. The smallest tubes. Water passing inside these tubes. After that, there is these tubes are made with integrated with the vents. And the air is blowing to these hot tubes. After that, the hot air is produced, which going to warm inside places. So that is how they basically heating system work. So in a cooling system here, we have this building, we have chiller. So again, we will see in which condition we have to use chiller, which design cooling load need to use chiller. So how chiller works in a cooling system. So basically here, the chiller produces the cold water, then pump it up to the air handling unit. Inside the air handling unit, we have the cooling coil. Cooling coil also consists of the small round tubes, then integrated with vents. So when the cooling coil, the cooling water moving inside the cooling coil, the fan blows the air. The air passing through this cooling coil, so the air loses its heat, and the air becoming cold. So after the air loses its heat, it transmitted its heat to the water, so the water becoming warm. So after water becoming warm, water is going back to the chiller. So it went back to the chiller to be cooled again. So this chiller, chiller condenser can be cooled in by using the cooling tower. We have a cooling tower up on the roof. So this cooling tower basically cool down the refrigerant inside the condenser. So also we will see how this more detail when we moving forward. We'll see how detail how cooling tower works, how chiller works. So that's why I was showing you how the system cooling the heating system. So we coming now to ventilation. So under ventilation, we have two types. So ventilation means putting the air inside the rooms. So also the air needs to be filtered through the different filters to remove the dust, and the other particles which will be harmful to humans. So generally we have two. We have natural ventilation. Natural ventilation, just when you open the window and the air coming in naturally, is natural ventilation. So mechanical ventilation, this one uses fans, uses ducts, it circulates the air through the building. So when we using the fans, whether with filters, putting the air from outdoor and then circulating it in the room by using the mechanical equipment, it is called mechanical ventilation. So example, here under mechanical ventilation, we have exhaust fans. Exhaust fan usually to remove the stale air in the space. We have supply fans. Also, we have air handler. Okay. So when we come back to our curriculum here, you can see we are defining the supply, return, and exhaust. I mean here in day two, designing ventilation system. We'll see how to design this supply, returning, the exhaust system with more detail. So under the air conditioning, we have a comfort air. The air conditioning system cool indoor air by removing heat and humidity. So when we see comfort conditions, we mean the condition which is favorable for us. So This one here, listed below as a favorable condition for indoor air. This one is acceptable favorable condition for indoor air. So the temperature condition acceptable as comfortable, ranging between 68 Fahrenheit, 75 degree Fahrenheit. So the main aim is design. This is a design tolerance main aim goal. 75 so minus 2 Fahrenheit. So that one, if you convert to degree centigrade, 68 Fahrenheit is about 20 degrees centigrade. This one is about 20 degrees centigrade. This is 75. It's about 24 degrees centigrade. So design goal is to design a system which will be providing the 75 plus 2, that is be 77. 77 is when you 77 degree Fahrenheit, it is 25 degrees centigrade. So the main goal is to design the system which will be ranging here. So this one is considered as a comfortable condition for everybody. So humidity condition acceptable as comfortable, ranging from 20% to 6%. So here the design goal also is 55 plus or minus 5%. Also, indoor air quality. Outside fresh air requirement for comfortable is 1520 CFM. This CFM is a velocity in terms of metric unit, in terms of imperial units, cubic feet per minute. So when you obtain 15 to 20 CFM person, that will be in terms of comfortable. So another thing in terms of comfortable terms in air conditioning is noise. So here, movement and distribution. For example, when we are in the rooms, the air moving inside the ducts, there's a limitation for air velocity, the noises. So for example, for you to feel comfortable, the duct system need to be the air movement noise level need to be limited to 30 to 40 NC. This NC I'll show you here. Noise, it's called noise criteria. So basically 30 to 40 noise criteria when we see in this graph which we show the noise criteria NC 30 to 40 is a very quiet category, also moderate noise. So when we design our system, for example duct system, we have to make sure we design the system and design the system properly to fall under this category. When you design, for example, duct and you oversize the duct, or when you make a high velocity, the air movement will cause a lot of noise. So that one will be uncomfortable. You cannot the place where there's a lot of noise, I feel uncomfortable. So basically, for the noise control and ducts, required design is this one. Falling under 400, it's so we have just looked how to understanding HVAC systems and components. That was about introduction, fundamentals, key components, the overview of heating, ventilation, and air conditioning. So now,
it's like 20 to 60. Relative humidity is 55 plus or minus. And here is 60 to 75, 75 plus or minus. Means like we go 77 or 75.
so the range here, for example, the temperature 64, 80 to 74, 75. This is acceptable, general acceptable range. But when we want to make it best, this one is a tolerance around 75 plus or minus 2. So you can see here it go above for 2 Fahrenheit, also below the 2 Fahrenheit. So this one is a desirable design goal. Yes. Also for this one, 55 plus or minus 5 percentages. When you're reaching to the regulating the cooling loads or ventilation design, the ventilation system will use mostly this data for CFM from the ASHRAE tables. ASHRAE standard, we follow the ASHRAE standards to design the required air ventilation according to the spaces type. For example, our workshop or gym require their own CFM, mean air velocity. For example, when a person is sitting in the office, not doing any physical activity, they require their own air, outside air requirement. We'll see. For example, a person maybe gym doing a lot of physical activities will require more air. So the requirement is different depending on the space, building space. We'll see more when we come to designing the ASHRAE. For example, here, this one is ASHRAE 62.1. So we'll size the system according to category of the building. For example, here cafeteria or food dining require the CFM 7.5. And here, when you convert this one to metric, it is liter per second is 3.8. So different types of the building have its own requirement, which is established by ASHRAE standards. When we came to sizing the ducts and calculating the cooling and heating loads, we'll see how more to manipulate these data. So we continue on. We can continue here to see another terms. Maybe there's a unit used in HVAC. So for mostly we're using rating, heating load, cooling load in terms of kilowatt or BTU, British thermal unit. For example, 1 ton for refrigerant air capacity in AC is equal to 12,000 BTU. Also is equal to 3.5 kilowatt. Most of the time when we came to heating load calculation, we'll use BTU in the ton. So for example here, when there are 24 BTU is equal to 2 tons. So for now, let's go back to Revit. Coming in number 3 is creating and configuring project templates. So as you remember before on Revit, here we are only overviewing the architecture model. We only see the architecture model. So for now, we close everything. We go to close everything here. Go here and close. First of all, you need to save that save this architecture model. You go to File. Before closing, save it. Go save as key project. So you basically select where you want to store it. Maybe everywhere where it will be easy to get it. So after saving it, we close, because this model we'll use it in the template. We'll insert it. So save a place where when we came navigate, it will be easy to find it. Here under the name, you can put it, leave it at this, or you can put it the name we want. For example, this commercial building, 6-story. This is just name of the file. Yes, so you can pay everything you want, anything you want. So here downward is select files. We only have one option, is Revit. So we come here. Option on the save as dialog, we came here option. So when we came to option, we have here the maximum backups. So I usually set this, you can set this to 1 or 2, because when you work on Revit, for example, you didn't save the file, so it's automatical backup file. So for example, I put here 3. It will create 3 similar files for my project. So when you put the greater number, it is the same file for the file. So it's better to put the small number, maybe 1 or 2. This one works. When you are modeling, you don't save your model. Remember that one when we are working on this file was when we are working on let me cancel this. When we are on option here, save interval time. Remember, so this one is automatically saving. So if I select maybe 30 minutes or 50 minutes, after every 50 minutes, the Revit will automatically save the file. So if I select the 3 files or 4 files, if here I select for backup, so Revit only will get similar 4 files. It's only for backup. So for example, here we can see they are 4 files of the same same information. So usually I like to set maybe to 2 or 1 in order to prevent severe usage of my disk space. So after that, for example, you put 1, you click OK, then you click save. After you select which location you want to save your model. So basically here select the space, the location which will be easy for you to navigate the model, because you will use this model. So select storage in here, the place you will remember. Example, desktop on anywhere easy for you to remember. So after saving this architecture, we closing it. Okay, so here in repeat again, here in the file, you go to options, general. This is called save remainder interval. So this one will every time when the time coming, it will remind you to save your project. Maybe after 15 minutes, the dialog will open and remind you to save your project. So if you don't save it, it will automatically create the backup. So this one generally is to help you when, for example, the system fail, you will not lose your work. You will also use the backup to continue with your work. So it is better every time when you wake up, you save your work. So we closing this architecture model. Now we are starting item number 3, which is creating and configuring project template. We will check setting up, mechanical setting, units, QAC systems, parameters. Then we will come to manage project standards guideline. So after finishing this number 3, we'll have a short break. So after closing the architecture model, we will have this user interface. Save it. So now we are starting to work with all of the features we discussed before. From the view, we check the out section. So now we are going to start how to work. So when you come to this activity interface, come here to under models. Under models, click new. Here under models, we click new because you want to start a new mechanical project. So we click new. So after clicking new, dialog will come up. We go to browse. We go to browse. Then after browsing, we show up with here we use an English Imperial. And under English Imperial, we have commercial, construction, default, multidiscipline, Kenback, commercial, residential, plumbing, mechanical, precast, structure, system. So here we will select the mechanical default. So when you click on Imperial, this drop down, you will have also the template here under template. So basically, Imperial I will use Imperial system as a unit. So if you want to use Imperial, or to use metric. If you want to use metric, you click on here on the Imperial. Then you click templates above the Imperial here. Then you click English without the name Imperial. When you open here, it will be the same like Imperial, but here we will use the metric. The default to be metric units. For example, here metric units, instead of you using the using the feet, be meters. For example, in a CFM, will be CFM. Metric will be liter per second. So for my side, I like to use Imperial. Also here is a template for different languages. So you can select different languages. So for my side, I'll use the Imperial mechanical default. So after clicking Imperial mechanical default, we going to open. Here we only have a template, only one option. Here leave what it is. It's a mechanical default. The file name is mechanical default. So we click open. After clicking open, we click OK. So just remember, for now we are number 3. We to check creating and configuring project templates. That is first steps. That's what we did. We create the template. So when we open the mechanical template, you will see something like this one. So as you see here, the units are in inches, feet. Example, if you scale, you see this one is the inches. So when you maybe use metric, here the unit will change to meters. So after this one, we insert model. We want to insert the model here to start working. Do you remember before I told you to save that architecture model? So we're going to find it in the link. That model, the mechanical, to start working. So, for example, if you want to change the units, for example, now we are in Imperial. We want to change the unit. So you come to manage. You come here on tab, manage tab. Then under setting, we have here this one, project unit. This one called it project units. So if you click it, you can change the unit and you can also mix if you want to mix Imperial units and metric units. So you can change. For example, here area we have square feet. You can change it to area to meter, square millimeter. Sometimes if you want to mix between Imperial and the metric, so that is how you change.
So when we selected English Imperial, it's affect the units.
Yes. So when you select the English Imperial, all the units on your working model will be in Imperial. Yes, for example, meter will be feet. Yes. For example, CFM cubic feet per minute. That's velocity. In Imperial that will be CFM, but in metric will be liter per second.
So suppose I want to have more.
So if you want to use the metric, we can go back to file. Then a new, click new, then project. First the top one, new project. Then you click the file, you go to new, then you go to project. Like this file, you go to new. On new, so another file, you put down your cursor, not clicking, only put down your cursor. It opens the option. Then you click project. You click project. So under the project, you go browse. Under browse, you'll see here English Imperial. So you click English Imperial. Above which there is a template. Click the folder template. Yes, you click template. Then you click English. The English plain name without any molds. That is metric.
English plain is for
Yes, English plain is for metric, and English imperial is for imperial. So depending on which one you want to use. Okay, so for my side, depending on what you want to use. So for my side, I'll go with the imperial. So visual participating. Sorry.
mechanical. English plain.
Wewe hapo kuna mechanical nani hiyo mechanical ni software okay. Unaweza kupa close kwa sababu hotel moja ile ya zamani nota imperial Indian metric. Kiangalia tu hapo kwenye hapo kwenye manage. Pale juu. Alafu ndio pale tumepolit tu. Mbona weka square? Unafanya nini? Sawa, tuendelea. Okay, now we continue. We come here. As I said before, we came to file new project and browse mechanical imperial. If you want to use a metric, you come to templates, English, and then you select mechanical default metric, this one, mechanical template, then you open. So when you open, you will have the metric units. So after opening this workspace, we want to insert the architecture model that we created before, we were viewing before. So we came here to insert tab. Under insert tab, we come to Revit, link Revit. So here we have to go where we saved our architectural model. So you go look around where we save your architectural model. So for my side, I put there at downloads. So depending on where you save yours. So after you locate it, After you locate it, here down the positioning, it is auto internal origin to internal origin. So you select internal origin to internal origin. Believe what it is. So after that, you click open. So when you click open, you will see that our model is in the middles of this small boxes, triangles. So as you remember, I select the internal origin positioning. So that's why the model, when you inserted, it appears in the middle of these small boxes. So this small boxes generally is a view, the section view. Example, you can double click this view from east, the section view. If you click this one on the right, view from west, section view from west. If you go back to this mechanical one, click this side, view from north. So when you click internal positioning, your model will be in the middle of these views. There are four. So over here, maybe you scroll, you don't see your model, you can come over here and you can zoom to fit. So this is the first step when working with mechanical template. First step, we have to insert the architectural model. So up to here, we inserted the Rivet model. So this one is the first step. Okay, sorry, visual participant. So as I said before, when you open, creating and configuring the template. As I said before, when you open the Revit, you came to file, then new, you click project. And this dialog will open. You can browse. You select the mechanical default. So this mechanical default is under Imperial, English Imperial. So we'll have Imperial units. So if you want a metric unit, you select this English Imperial, then you select the template, then you select this English, the word English plain without any word. Then when you open it, you select the mechanical default metric. After that, you open. So here, when you open, you will have the metric mechanical default template. So now, after inserting this, architecture model, we're going you can go to check this section. So here is select this the left triangle, the upper triangle. Right click. You click go to elevation. So visual that one it shows the elevation of this building. If you want to look this side, you want to look north, south, east or west. So that is the usage of this small box. You know, this is elevations. You see, it's elevations. Okay. So if you want to view the 3D view of this model, you come here to the small icon with the house. You click it, you'll open the 3D view of this model, as you see. So as you see here, our model is like you can select here, you can change the wireframe, you can change the way model looks, you can change hidden, shaded, depending on which graphic option you want to see. Okay. So for now, we want to check how to set up units and parameters GVAC systems. We want to look for these 3 items. So for now, we already created and configuring project template. Now we're moving to setting up mechanical settings, which include units, GVAC system parameters. So as I said before, if you want to units, you come here manage, then you come here to project units. So there is a shortcut. There is a shortcut to this. You only type UN. On your keyboard, you type UN. The word here UN. So this is a shortcut to project units. So when you type UN, you can set the project unit. For example, now we are in GVAC. So we drop down menu discipline and select the GVAC. So because for now, for me, I'm using the imperials under the airflow. You can see there's a CFM, big feet per meter. If you want to change it, you can change it according to the list below. If you want to use liters per second, or if you want to use liters per minute, you can change it. So there is also airflow density. Here you can select if you are on metric, probably it will be liter second square meter. So if you come to cooling load, metric default is BTU hour. When you are in it will be maybe in kilowatts. When you are in metric, it will be in kilowatts. Sometimes maybe if you want to use tons of refrigeration, depending on which one you want to use. So here you can configure the units depending on which units you want to use. Temperature, you can select Celsius if you want to use. So eventually you can mix the project unit, you mix imperial and metric units if you want. So that is how to set the project unit. So under here, we are still under here. You can set the location of your project. You click location. Then click internet mapping services. Under manage, click project location. There's a world map with the pin. So there we internet mapping services. So the project address, you can select. You can type the city in which your design project is. So after that, you click search. So basically here, this one will help us to during the designing, during the selecting the cooling load calculation. When you select the location, you pass on heating and cooling load calculation. So you have to select the location of the project. So also you can drag this. There is a home button. You can lift and drag it, drop it where your location of the project is. For example, now I move it to Dar es Salaam. On the map here, you can find your region. For example, here I drop it in here. Move and drop it location where the project is. So after drag and drop that pin location, you click OK. Click OK. So that is how you can set the location of the project. That will be useful when we are on a pooling load calculation. So we continue back to settings, manage settings, and we are going to set the project parameters. So here there's a small palette here of project parameters.
Okay.
So under project parameters, you click it. Repeat again here on selection location, take the location. So the manage tab, you come to project location. So you click this small map. After you click this one, this dialog location, the site will open. Make sure the internet mapping service is selected. Then you come to your map as a pin is a home. Move it to location you want. So move it to the location in which the project is located. For example, move it here. After moving it, you click, automatically it will change here the latitudes, the longitudes of the place. Then you click OK. You click OK. Sorry, visual participant. I'll get back to you soon.
Concentration. Ukistaka sana na hivyo tu ukisipoenda
Pwede lang check.
Unaona kwenye parameters.
Ah,
Toka poa vile.
basi poa.
Vile 30 minutes kuacha.
Okay. Hello. Now let's go. Let's have a 30 minutes break. Then we'll continue. We'll continue on setting up mechanical systems and the managing project. We continue on with our Polygram. So after 30 minutes, we'll be back.
Thank you, engineer. Mubarak, can you hear us? Mubarak Olamide, can you hear us? We're going for break.
Yeah, I can hear you. I'm here.
Okay, that's perfect. That's perfect.
So when you go to manage and setting, here we have project parameters. Also we have project unit. So under project parameters, when you open project parameters, it comes dialog. So this project parameters will help us on during scheduling. This project parameter will help us during scheduling, sorting and filtering in the project. So we are grouping the parameters according to discipline. So for example, here when you want to create a parameters, you come here, there is a new parameter down here. You click new parameter. Yes. Then here project parameters. You mark project parameters. Then we come to name. The name which you wish to give. Maybe we can deal with HVAC. We call it HVAC. Maybe 001. Discipline, we select HVAC. So data type. For example, when you are working on, you want to create parameter for duct size. For example, when you want to create it for cooling load, so you select. So let us see. Select the duct size. Then group parameter under. You want those parameters to be on which group. For example, we can here we can select the mechanical. Select here mechanical. So in here on categories, we came and we filled out and select mechanical. Then we everything related to mechanical. You can check all here. So when you set like this one, you can click OK. So when you click OK, here we'll have the HVAC 001. So you already set the parameter for HVAC. So for now, we have created the project parameter for duct size. So these parameters will help us when scheduling or for sorting or filtering in a project. For example, we can create the second parameter. We can do new parameter here. We can call it maybe HVAC 002. Discipline HVAC. Then data type, with the parameter maybe heating load. When we meet this section of heating load, we use as well parameter. So select heating load. So group under also mechanical. Select mechanical. And here we check all the categories. Check all. Then click OK. So here we have one for parameter for duct size. This is for heating load.
So you can write as the duct size for heating load.
Yes,
Because you wrote the 001.
Yes, of course you can add if you want to change this one name. For example, this one is for duct size. Let's change the name to duct size. So you select this one. This edit. Yeah, and you can type dash duct size. Okay. This one is for heating load. Click that one, then you come this. Then you call cooling load. Cooling load. So we have created two parameter. First one is duct size. Second one is parameter for cooling, heating load. Here the heating load. Go to this heating load. Parameter mechanic. Select the mechanical plane. Here you select the group, select the mechanical. Then
There is a macro.
yes. Yes. So if you want to edit, you cannot be able to change the discipline. You are able only to change the name and the group. The discipline and the data type will be possible to change if you want to edit. Yes.
001 ilikuwa ni nini?
001 was the
One
dark
dark
size.
size.
Dark size. You can name it.
Yes, you can put it the correct the full name as it is. That is size instead of numbers.
You see, when you put the name here, it will be easy to remember. So you can maybe create another one. Yeah. Number 3, write HVAC, maybe 003. The data type. This one is HVAC. Data type maybe cooling load. Then you come here writing cooling load. Group parameter under, choose mechanical. Then we came here and filter mechanical. They check all. Then click OK. So you can create multiple project parameters depending on the data. Then you click OK.
That is basic parameter.
Penny.
So, for example, if you created a lot of parameter here, you have a lot of data. You can filter here if you want to select. Maybe you can select maybe project parameter. You can filter according to discipline or all. For example, here you can filter. For example, when you say TVAC data type, maybe size, you can filter and in terms of your many data here. Okay, so now on the project units, as I said before, you can type UN on your keyboard. You can type UN. You can see here you can set the units of the project. Imperial or metric, or you can come here in the project units and manage system template. System panel. You can come here and select. So On this mechanical template, we have a project browser. We have this one is a project browser. This one left corner. So sasa lingine is we have here, we have properties here, we have project browser, and we have here system browser. So for example, if you want to, if you close this one, and you close project browser, and you close this system browser, you will plain model like this one. So if you want to put them back, you come to view. Yes, you come to view. Because this project browser will help you to select, for example, the levels, or to select the systems, for example, supply system, return system. So when it happens, you close them. To put them back, you come to view. Then you come to user interface. Here, it's user interface. So under user interface, you click project browser. You come again under user interface. You click system browser. You come again under user interface. You click properties. So system browser. Yes. Yeah. So under user interface, down we have keyboard shortcuts. So when you click it, yeah, you'll get the shortcut, all the keyboard shortcut for Revit. So for example, if you forget where you can find units.
Engineer, we can't see the screen.
You can see the screen.
Yes. Oh, we can see it. I can see it.
Okay. So I was explaining that when you, for example, you close these properties, the project browser and system browser. So how you can put them back? So you come here, view tab, then you come here, user interface, and the browser. You come again, user interface. You tick again, system browser. You come again, you tick again, properties. So as you see, they are back. So under user interface, we have the last option is keyboard shortcuts. Assume you forget every command. So the easiest way to remember is using keyboard shortcuts. You come in the keyboard shortcut, you click, then under search, for example, you type units. It will show you shortcut is UN and path manage setting. So it will be easy for you to work. For example, you type section. It will show to you where you can find the section. View create quick access bar. For example, you want maybe to split duct. You forget the command, you only type split. It will show you where you can find this command. So the shortcut, for example, is SLO. So it is under modify. So when you forget something, command will come there, it will be easy for you to find it work. So when you look at this system browser here, when you look at system browser here, we have systems. We have mechanical, electrical, but you see here we have 0 systems. So now we're going to assign system. So as you remember, we have supply system, exhaust system, and the return system. So how to assign system to your model? So let's do that here. Let's do that. If you want to do that, we come to system. Then you come to duct. So when you select the duct, before doing anything, you come on properties. Here on properties, you scroll down, and you select the system type. So here we have 3. We have exhaust, we have return, we have supply. So when you draw, for example, when you draw the system without, for example, without selecting here, and you draw apply, it will be very hard to change the system. So first of all, before assigning your duct, come here to the system type and assign the system type. For example, now we select supply air. Then we hit OK. We apply. So when you come, for example, here we draw duct. Here we selected the, for example, we selected the rectangular duct. Then you can draw. So you can see here under the system, now we have one system. From 0, now we have one system here. And the system is called the supply air. You see? So you can see now we have one supply air system. So if you want to select this system, you can come here on mechanical system, plus button, then you plus, then you select the mechanical system. You'll be selected as the whole ducting system and mechanical and supply air system. So here you can, when you click show, it will give you different views for this supply system. So you can click show. It will give you the different view. Click again show. So that now is finished. You say you want to repeat again, say yes, okay. You can start again. So that is how to see concern the mechanical system or supplier system.
So,
Okay, let me repeat back this part.
First, I think we're supposed to know how many systems we have. Because we started with the
So let's repeat back this part, HVAC system. Let's repeat back this part. So let's repeat back this HVAC system. Setting HVAC systems on a mechanical template. So let me delete this system and we repeat back it again. So we have this mechanical flow plan on the system browser. Mechanical flow plan 1.
yeah.
So we have this one. We are going to create the system. Okay. So now this is system tab. We're going to create a system. So as you see, this model, no any mechanical element here. HVAC mechanical element, and here the system is becoming 0. Under the system, you can see here is a 0. So we are going to assign system. So let's come to system here. Another system tab, this one. System tab. This is a system browser. This is system tab. We come here and select the duct. Select the duct, right? I mean, left click one time. Then you come here, area. Cursor will be changed to cross sun. That was distracting. Here we have a model without any system. You can see here the system is 0. Mechanical system is 0. No assigned system here. So how to setting up a system.
Ready. Na baada step hapa baada ya okay.
As you see this model now, that it doesn't have any system. Under the system browser here, we have 0. So how to assign system? First we have to create the element. For example, here we come to here system tab. We come to system tab. Then under the system tab, we come to duct. Before starting drawing, you have to come to properties here, properties. Under properties, you can select the type of duct you want to draw. For example, here we have oval, we have rectangular, we have round duct. So you can select type of duct which you want to draw. Then you come here to mechanical. Then you select the system type here. System type. So system type, we have exhaust, we have return, and we have supply. So and here also upward here you can set the size of the duct. We'll see in the coming how to size the ducts according to the required CFM velocity, air velocity. So as for now, we'll go with this value which appeared here. So we come to this area. You can start drawing. So you left click one time. You hover to the right. Then you click one time again. Then you hover up to here. You left click one time. You go left. So you can see here after finishing drawing this duct, you can see here the system now become one. We have one system, mechanical system, HVAC, but for supply here we have only one system here. So now you can select this system. If you want to select this system, you this plus sign, then down one will have a mechanical system. If you want to select this system, right click, you select. That will have select this system. So here you can show this system. You can view it in different views. So if you click show, it will dialog will come up and show multiple times different views. So you click show. Okay. So it will show you the system on different view. You click again show. Click again show. So you click again show. So it will guide you to different views. So as you see now, we have only one system here. We want to add a second system, different system. So we can let's go back to our mechanical floor plan, mechanical one, original floor plan, where we draw this first system. So now we can create a second system here. We go back to duct. Then after clicking the duct, we come here and we assign, for example, return air. Return air. Assign returning air. We come here, apply. So when we come here to draw, when we draw here, it also change the color. So which means that we have another system. So that's why you see its color change now. When you look here at the system, additional system added, now we have two systems. So you can see here, this pink color is another system. Also this blue is another system. Also here on you can see we have two mechanical systems. You can extend here. You can come here and extend it to see more. So here is the supply. Here is a mechanical return. Same if you want to select this mechanical return, you just right click, then select. Also you can show it, see it at the multiple views.
How the position of the duct is a bit. The position of the duct on that is. I don't know if it's on your side or your side.
So now we just created this two system. So if you want to section and look how this system on the section view, you can come here on the view, you come section, you select this one, create your view, then you can change flip section. You can make like that one, select only this one system, Then go to view. You right click to go to view. So when you go to view, you see here there's a crop region. You can extend this crop region. So here you are seeing like one line. This is only one line. To increase it, you come here and select define. There's a coarse, medium, define. You click define. It will change to view. So here also you can change it, shaded. So as you see now, this duct is below level 2, below level 2, or above level 1. So you can set this duct 80. When you select it, here is the elevation from the depending. So reference here, this is elevation from level 1. You can choose the elevation maybe from level 2. For example, if you choose elevation from level 2 to be, when it is down the level 2, be negative. So, example here, we have 9 feet from level 1. Here's a reference line, level 1. So, for example,
You can say like what is the ground?
so yes, level 1 is the ground level. So for example here we want to maybe to locate this duct to come here in the middle elevation. For example, we want to put maybe 60 centimeter below level 2. So you select here level 2, and here in the elevation you can write. Now it is in period. If you write meter or centimeter, it will automatically convert it. For example, 60 centimeter. It will automatically convert it to the imperial. So I write negative here because it is below level 2. This one will be supplied here to level 1. So if you change, you can change here the reference line level. Also here it will change. So let leave it at 9 feet. So as you see here, you can increase the crop region. And I'm managing the project project standard and guidelines. There's something called owner project requirements, OPR. So owner project requirements. So basically, owner project requirements as a wish list of the owner on their projects. So the owner project requirement will include something like budget criteria for the projects, Also, it will include the occupancy requirements. Also, it can include equipment performance requirements. Also, it will can include the indoor air quality requirements, AQ, indoor air quality requirements. So, also it will include it can include commissioning requirements. Sometimes the owner project requirement of TARA might include the sustainability standards. In the sustainability standards, the client might need the design, the installation of HVAC systems, maybe to follow the net zero carbon emissions or green building standards. So it might also including these standards. You know, when these HVAC systems installed in the buildings, they are going to last for forever. So it's not like maybe you're building a wall. So this system will continuing operating during the lifetime of the building. So they need to design it according to, for example, making it maybe green energy. You can use it, you can accommodate it by using this solar energies, other types of renewable energies, atom energy, and their energy efficiency. So this might be included in the owner project requirement. So let's go and see example of owner project requirement. So you can come on your browser, come on your browser, and you can type for example, let's see owner project requirement of Ashirai building. You can type Ashirai. You can type Ashirai Opiara. So let's review this Ashirai Opiara. You can come here and download this one owner project requirement draft. So when you download it, you have the PDF like this one. So this is the owner project requirement. So when you design the HVAC system, this client wanted to follow this requirement. So the minimum critical requirement that it was stated on this building, that means the system should meet this minimum. This is mission critical, means that minimum need to meet this one standard. These are criteria, and this is highly desirable. So, for example, here I say safety during construction and building operation. So, for example, here they say affordable and the appropriate to the budgeting program. So you can see here how the owner need provide the guideline for which standard. So another thing here, you can see number 3 has stated that exceed the requirement of ASHRAE standard 19.1 2016, 62.1 2016, 52 and 2017. So also you can see here they say that the sounding produced also to exceed me by 3 to 5. This is a requirement, acoustic requirement by the client.
Sorry, it was 30 to 40.
This one written that office space shall also be designed to exceed 3 by 3 or 3 to 5. So you remember last time we discussed the 30 to 40. So but here he say you can exist by 3 to 5.
From 30 to
So it means that this may be a tolerance. So from here on this noise criteria, it give us a tolerance of 3 to 5. So for example, 45 will be acceptable, or maybe 27 will be acceptable. Always below value is good. So and the range, when you design that your system, you have to consider that noise criteria for room. So this is a standard, is a requirement by ASHRAE. So another requirement was net zero energy building rating to 100. So they want when you design the systems without any emissions to the maybe environment. So for example, these refrigerants, they are refrigerants which affected the ozone layers. So they want you to use the refrigerants which does not affect the environment. So when you design your systems, you have to consider these guidelines. So for now we can see there are this one refrigerants which are environmental friendly. We have R40A, we have R407, R3, R13A. So when you design your system according to this guideline, net zero energy, you have to considering using this environmental friendly refrigerant. So you have to consider all the requirements. So let's look this one again here. You say again here, I say deliver outside air at value of at least 13 times the required standard 62.1 outside air. So what is 62.1? Let's see. Standard is 62.1. So let's come here and write ASHRAE 62.1. So this ASHRAE standards as a confidential document. So, but it's the only PDF which is available for online only. So here we like online. Get it, read it online. Otherwise, if you need the offline, you can purchase it. So read only. You can write ASHRAE 60.1 online, or you can write read only. So here it will come read only version for ASHRAE standards. You will not be able to download it. You only read on the internet. So if you open it, here is we'll try to find here 62.1. So you can click Control find 62.1. So here is a 62.1 standard ventilation. It is standard ventilation and acceptable indoor air quality. So click it. So here is a standard for 62.1. Let's see what this means. Deliver outside air at value of at least 1.3 times the standard is 62.1. So let's go to the table. When you go to this occupants, table 6.1. For 6.1, which is say the minimum ventilation rate in the breathing zone. So ASHRAE says that exists this standard by 1.3. So how do we use this information on designing our model? So we come here to Revit. We come back to Revit. This portion, as you remember, this portion is cafeteria. This portion is cafeteria. This area. So when you look here under food and beverage services, you can see here cafeteria required CFM per person is 7.5. So one person, according to ASHRAE 62.1, in a cafeteria area will require 7.1 CFM. So when we come back to our model, we can see here we have round tables with chair. So we can count this how many chairs in order to know how many people will be accommodated in this place. So as you can see here, we have we have 8 tables, and each table have six chairs. So So here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 around the table. We have 6 chairs. So 6 table, 6 round table. We have 8 round table. We have 6 chairs. Yeah, you can see here. 1, 2, 3, 4, 5, 6. The total design is 8. So people here will be 6. Be 8 times 6. 48. 48 people. So also you can see here we have here this table. This is a table. As you remember, we can open the architecture model. You see, this is a table. So let's assume maybe this is a table for services, maybe waitress. So let's assume which table 2 waitress. So here we have 1, 2, 3, 4. So we have 8. So total occupants will be 56 people. So when you refer to Ashrai, they say they need for cafeteria, CFM per person is 7.5. So when you came back to this table is page number 19. Page number 19. Remember, this is a read only. You go to page number 19. Table 6.1, minimum ventilation rate in breathing zone. So 56 people. So we are to CFM category of CFM per person. Will be 56 times 7.5 will be 420
Safe.
CFM. In our model here is a cafeteria area. We say that we have 80 round tables, each one have 6 chairs. So we have a total of 80. So 48 people. Also, here we have a table for serving. Maybe we assume each table have 2 waiter or waitress. Save that 48 people. So 4 table, 1, 2, 3, 4. Each one will have 2 waiter or waitress. So that's why we put 8. So total number is 56. So according to Ashura standard, cafeterias, fast food dining, required air, outdoor air, 7.5 CFM per person. So we times by 56, we got 420 CFM. So that is case 1. Case 2. The Ashura is outdoor area rate. So here it requires 0.18 CFM per square feet. This is one is imperial. In metric, 0.9 liter per second per meter square. So if you use metric, here we'll use liter per second. So if you use imperial, we'll use CFM. So for my case, as you remember on the project units, I selected imperial. That's why I'm using CFM. So if you selected metric unit, you'll use liter per second, or we'll use liter per second times meter square. So for cafeterias, we need at least 0.18 CFM per feet square. We need 0.18 per feet square. But we have to see here we have how much area, floor area for cafeteria. So we can measure to see how much square area we have here. So the easiest way to measure this one is to create the space. We can create the space and measure this area automatically without using the manual way. So we want to measure this automatically. So select this model, then we can edit type here. I select room bonding. This is room bonding. So you do this room bonding, then you apply, then you okay. Then you come to analyze. You click space. If you click space and if you come to this cafeteria area, you can see automatically there is a this across. Automatically select this room floor. With your person model, you can even if you come here, it automatically select this space. You can see here. So for now, I'm clicking this cafeteria area. So if you click it, the color will change. So this is space. Now you can come here to the properties. It will give you here the area. The dimensions here, we see the area is 131.0 square feet. 131.0 square feet. This is a square area of this cafeteria area. So I'm repeating again. I'm repeating again this. This is we got 420 CFM. We got 420 CFM person. This is case 1. So case 2, we're going to CFM per square feet. So here in cafeteria and food dining, it is 0.180 square CFM per feet square. So I need to measure at cafeteria area how much area do we have. So easiest way, I came to click this model. When you move the cursor to the model, click, then you come edit type under properties. You click room bonding. After taking room bonding, you click OK. So after clicking this room edit type, you come to first you click this Revit link. Make sure you click Revit link. Then you came to edit type. So you click room bonding, you click OK. After clicking room bonding, you come to analyze tab. You come to analyze tab, then you click space. Then you click space here, space. So when you click the space, when you move the cursor to this cafeteria area, you can see it's automatically click space. Automatically creating space on Moodle. So we click space. So after clicking this cafeteria area, we came here. We see the area. The area is we came here. We see this area 131.02 square feet. So the area we got is 131. You can see here 131.02 square feet. So here are total CFM. .18 times 131.02. We got we got 23, 20, 20.6. So we approximated the nearest fifth number. So it will be 25 CFM. So total required outdoor air. You take C1 CFM plus and S2 CFM.
So this is a total required CFM for ventilation. So we got total required CFM for ventilation. This is only for ventilation, not for cooling load. Only for required outside air, only for ventilation. The cooling load I will see when we are continue moving forward. So when you refer to the project line, he said that exceed this value by 1.3. Say they leave outside air at value at least 1.3 times the requirement of 62.1 outside air. So as you know, we have to times 1.3. So it comes by 1.3. Got 578.5 CFM. So also we approach this to nearest fifth. Be 700. 7 CFM. So according to the project guidelines, this is how you calculate outdoor air. So when the client when you commission the system, the client will come with the commission team. They will measure the outdoor air if it reaches this value. So if it not reaches this value, means that you did not meet the requirements of the project. So when the commission team coming, they will measure the airs, and when they get to this value, means that you follow the required project standard and guidelines. So that is all about managing project standard and the guidelines.
That's the term of nutrition.
Hello, Mr. Mubarak.
Hello, I'm here.
Yes, as you see, we are on managing project standards and guidelines. So that is
Okay.
how we can manage project standards and guidelines.
Okay, sir.
Yes. So as I go through this example for this cafeteria area, and I show you how
Yes.
it is done. So
Yeah.
you can do it for
Yeah,
other
sure,
spaces.
Yes, because here we have office spaces here. So by following this guideline, actually,
62.1.
yeah, it is easy for you to go step by step and doing for another places. So, for example, here is an office building. So, I think now that part is finished. So, give me like 5 minutes. I will come back to you. Give me like 5 minutes. I'll come back to you.
Okay.
Hello, Mr. Mubarak.
Yeah. Hello, I'm here. I'm here.
Yes, yeah. As you can see, we are remaining is
Please, I ask a question. Please, kindly attend to that question on the chat.
on the chat.
Yes. I didn't understand something.
You mean on the Ashrai chat?
No. I was
Yes.
trying to do it from here. I'm not getting area. The room boundary is saying not enclosed.
The room boundary say nothing closed.
Yes. It's not giving me the area.
Can you mean that if you select the room here, you cannot see here the
Yes. I was not able to select the room set.
Okay, can you please share that just on my WhatsApp screenshot of that error message.
Okay.
I'm texting you now on your WhatsApp.
Okay.
Yes.
I will message you now.
Yes. So I think for now.
Hello, I'm hearing you. I will send it to you now. I want to connect my phone.
Okay.
No, I don't think so. I don't know. See, she has come. What else?
Yes, Mr. Mubarak.
Yeah, I'm there.
For now, I think we want to close the session for today.
Okay.
So this remaining part will start early tomorrow because sorry. I'm texting you now. I'm texting you right now. I'm texting you right now. Don't worry. I'm texting you. Don't worry.